Hi everyone. In this video I'm going to walk through an example demonstrating how to create a contoured object using Rhino. As you can see here on this Pinterest board, these are some examples of different types of contoured objects, and some are created in the end with plywood, some are plastic, some look like they might even be made out of metal or glass, they serve different purposes. Some are artistic models, some are sculptural things, and others might just be different types of form studies common in architecture and design. So I'm going to start off by showing what we will walk through. This is a file that will result in creating a contoured object out of the Stanford bunny, which is a very common 3D model in computer graphics. It's sort of a reference object for mesh algorithms and different types of 3D model algorithms. And so we'll use that object to create this contoured model and in Rhino. So let me go to starter here. So what we'll do is we're going to walk through the process of contouring this object from mesh to what you see in this file right here, which if I go to my perspective view, I can kind of zoom into this right here. This is the final bunny object, and you can see it consists of several layers that are all 1/8 of an inch thick. In the end, this object is around 4 inches tall. So in Rhino, I could go here and create kind of a shaded or a rendered looking version of it by changing the render mode. And you can kind of start to see, give it some depth just by rendering it differently. So I'm going to go to a starter version of this file, which basically consists of, to begin with, a mesh. And if I click on this object, you'll see it says closed mesh. This is sort of a low poly triangulated version of the bunny. And to get a sense of the volume of this, I can type bounding box and hit enter, and it creates an object that is 4 by 3 by 3.8 roughly around the object that I selected. So that's a really good way to just see what size your mesh is when you bring it into Rhino. So what I did to get this in here was I imported the mesh from a STL file. So this could be something that you download from Thingiverse or you build yourself. My original model was actually in millimeters, but I'm working in inches in Rhino. So if I import it, this is what I get right here. And then I scaled it up to get to this size. So again, you can model something and bring it in, or find a model on Thingiverse or somewhere else and work this way. So once you have a mesh in here, it's convenient to convert it to what's called a NURBS object, which is what I have right over here. And really what that command is doing is it's taking this object, which I will demonstrate here. So select it and type mesh to NURBS to NURB. What it's doing is it takes the mesh and it converts every triangle on the mesh into a surface in Rhino. So now see it says closed solid poly surface. If I toggle off the ISO curves, then I can kind of clean it up visually. So you can see it consists of all these triangles, and if I were to explode that, then it would break it apart into different surfaces that I could then further manipulate in Rhino this way. For our purposes right now, we're just going to take the mesh to NURBS object, so the poly surfaced object, and work from that point on, just because it's easier. So, and if I were to change anything, I could change it on this model and leave the mesh alone. Okay, so I have this object. I'm going to zoom to select here, and I'm going to go to my front view, and this is the object I'm going to contour. So the easiest way to go about doing this is on your object, you can type bounding box and create a box around it, and then you can use this box as a reference, or in this file specifically I created some little guidelines to just use to snap to with the snaps on the side here for contouring. So I just drew a line like this down at the bottom and drew in that matched up here on the top. So sort of like that, you create some little guidelines to snap to. And so what I'm going to do here, I'm going to remove my bounding box for now. What I'm going to do here is contour. So use the contour command, enter, and it says select objects. So I'm going to select this object. I can also have group objects by contour plane on if I create a contour and there's multiple pieces to it. In this case, this model does not have that, so it's not an issue. But just know that that's an option if you need to group curves that are on the same plane. So I hit enter, and then I pick my first point of contouring, which is the bottom, and then I'm going to hold shift and go up to my top point right here. And now I want to specify the distance between each contour. So thinking ahead, I might fabricate this out of 1/4 inch acrylic or plywood or cardboard. So I'd want to specify the thickness of my material right here. So I'm going to say 0.25 inches, so 1/4 inch, enter. And I can bring these curves over. And maybe that's, let's look at it in the perspective view. So zoom select. And so we can see here our contours, and maybe I actually want more contours to be able to really, make out the shape of this object. As it is right now, it's sort of hard to tell what it is, and if I were to extrude these and look at it, it's going to look really low resolution. So maybe I want to double the contours here. So I'm going to delete that one and go to my front view here, contour again, and go from here up to here and do 0.125, so 1/8 of an inch. And that's looking good. So then I can move these contours over so I can see it in my perspective view. And there we go. So we have all these lines that represent different parts along a direction of this object. So that's good. I do see there's sort of an artifact on the bottom piece right here. If I click on one of these, you can see there's sort of pieces that aren't connected properly. So we'll have to fix that. But the contours look good. So what I can do here to be able to fix this bottom piece is select everything above that and just hide it quickly. And then go to my top view and let's fix this bottom piece. So I'm going to select all this and explode it. And then just delete the interior pieces like that. And then select and join to create one closed polycurve. So go back to my front view and type show. So it brings everything back that was hidden, which was just those curves right there. And so now my perspective view, you can see I have these objects right here. So that's good. So the next step here might be to visualize these curves as surfaces. So I can use a command called planar surf. Planar surf, and it'll create a planar surface for each contour. And you can see it created them right here. I'm going to click off of my object and type cell srf select surface, and that'll help me select the surfaces in my file. That will select everything if you have other surfaces, but this will just select the current surfaces that I have here, and then I'm just going to move them over to where it says planar surf right here so I can see them. So if I select these and type ZS, enter, I can see what my surfaces look like, but they're not extruded. So this is if I were to make this and use like pieces of paper or something. So similar to maybe an object like one of these sort of very colorful examples here or something like along these lines, where you have sort of some separation between different layers for a different kind of effect, or something similar to this right here. These contours are just spaced further apart, and that's sort of accounted for in the model overall. So you can do something really interesting with these types of contours as well. For right now, we're just going to look at how to just visualize the concept within Rhino using extrusions. So if I go here, I'm going to go back to my contours here and type extrude curve. And then it looks kind of like a big mess, but what it's doing is it's asking me for how far I want to extrude. What's the distance that I want to extrude? And so I want to extrude vertically up the same distance as my contour spacing is, so my material thickness. So 0.125 inches. Okay. And so then what I can do is, there's another command, cell extrusion. So cell extrusion will actually pick the extrusions that I just made right there. And I can just go ahead and move those over here. So right about there. Whoops, I actually want to do cell extrusion. There we go. I want to leave the original curves where they were, my contour curves right there. I could also do a copy and bring things over, but this is a little easier. So I'm going to group those. So I have a group. And I'm also going to toggle the ISO curves so I don't have any extra lines. So there we go. So I have this 3D model here now, which has, let's see, 37 closed extrusions. So that would be 37 individual little pieces stuck together, layered on top of each other if I were to cut each one out. And so that's pretty cool. So with this, I could say it's done. I could say, you know, I have a kind of a nice render of this concept right here. And I could use this command, screen capture to file, and save out a, let's just save it on my desktop, save out a JPEG or a PNG or something to, let's see here, to see what my model looks like. So that would be just a quick screenshot. I have some extra text and stuff in this picture, so just ignore that for now. But that would be a way to get a good screenshot out at some direction. So whatever your viewport is set at, you know, it's gonna capture that in the screenshot, and whichever render mode you're set to, it'll capture that as well. So if I would like to, let me go back to my top view here now. If I would like to go a step further and make a nicer kind of line drawing type render, I could use the make 2D command. So the way you do that is you pick your object and you type make 2D. In whatever viewport you're in this case I'm in the perspective viewport, you can choose which view you're in, and you can customize the make 2D command a little bit with these options. And you say apply, and it's going to create a 2D line drawing version of this model, and it's going to drop it in the top view. So if I go to the top view now and zoom out, I can see, just going to bring it over here, I can see what that looks like right here. So I have, you know, a 2D version of a 3D picture or a 3D model now. So it's flat, so I could save this out and open it in Illustrator and create, you know, a poster or a, you know, a pamphlet or whatever kind of visualization of this, because these are just paths that could be mocked up in any way with color and fill and stroke and line thickness and stuff like that. So you can get creative with how you render a model using Make 2D. If you want to get back to a certain kind of perspective, so say I move my camera like this and I actually liked where it was, I can go over to what are called named views, and I can go back to one of my views as you can see here, I can go back to a fixed view. So if I move it, I can go back to it. And the way you create these is you pick your kind of angle that you want to create a view for, you know, right here, and you click the plus and just give it a name, my view, and then it creates a view for you right here. So if you move the camera, you can get back to it. So this, in combination with Make 2D, is really handy for saving out different kinds of pictures as line drawings. If you don't see the Named Views tab here, you just have to click on this little gear and toggle it on and off right here, because by default it might be off like that. So toggle it back on. So if I would like now to go back to my 4 view and even change between different views right here in the viewports, I just have to right click on it and I can set the view back to my perspective like so. So there's a lot of flexibility just using these viewports to see different parts of your model. And you can always kind of get back to the default top, front, right, and perspective views, even while using name views like this. So that's all I have for this video. Hopefully this is helpful for going through the process of taking a mesh, converting it to NURBS, and creating contours for a 3D model and rendering it. Thanks for watching.